A tree is a different data structure in a sense that is not sequential, like stacks, queues, dictionaries, and etc. It is an abstract data structure that simulates a hierarchical tree structure like a family tree, for example. It is composed of nodes, and these nodes have parent-child relationships. The topmost node is the root node, and that's the only one with no parent. Each child node is essentially a subtree, as it may contain its own child nodes. A node with no children is often referred as the leaf node. They are on the edge of the tree. Every node above a node is known as the ancestor nodes, and every node below the node is known as descendant nodes. Both ancestors and descendant nodes are measured in depth. A node is said to have a depth of 4 when counting from its parent all the way to the root node. You count 4 nodes. There are also many types of trees, and since you have worked on the web, you probably heard of the DOM tree. The file system in your computer is also a tree. In a sense, object-oriented programming is pretty much creating trees with classes with single inheritance, and all classes are pretty much nodes. DOM tree and file system trees fall into the category of unordered trees, which pretty much means that the order of the nodes are not important. There are more unordered tree types, but these are the ones you are mostly familiar with. If you ever heard of Fibonacci and binomial trees, these are examples of ordered trees. Another example would be a binary tree, which is a tree that contains 2 children at most, where the left node value is less than the parents and the right node value is greater than the parents. Binary trees are used in a famous search algorithm called binary tree search, and a binary tree itself have different types. Another famous binary tree is the binary heap, which is used in a famous sorting algorithm called heap sort. A binary heap is a special binary tree in a sense that it is complete, meaning all nodes except for the leaf nodes have both of their child nodes. Another famous binary tree is the AVL tree, named after its inventors Anderson, Velsky, and Landis. It is pretty much a self-balancing tree, which means that the height of the left and the right nodes differ most by 1. As you can see, tree data structure is a serious topic, and it will be my pleasure to walk you through popular concepts and implementations, and I will be showing you how to implement and use DOM, file system, binary, AVL, and binary heap trees, and look closely at each differences and algorithms so you have a better idea of how to use them in the wild. Make sure you are subscribed and notification is on, and let's dive into the tree world. Thanks for watching. Catch you in the next one. Bye-bye.